The Airbus A400M is a multi-role military transport aircraft that is known for its impressive performance, versatility, and advanced capabilities. The production process of the Airbus A400M involves a complex and highly coordinated effort that spans across various stages, from design and engineering to manufacturing and final assembly. The production of Airbus A400M begins with extensive design and engineering work. A team of skilled engineers and designers work together to develop the aircraft's specifications, performance requirements, and systems integration. This involves computer-aided design and computer-aided engineering processes, including 3D modeling, simulation, and testing, to ensure the aircraft's structural integrity, aerodynamics, and overall performance. Once the design is finalized, the manufacturing process begins. The Airbus A400M is a complex aircraft that requires the fabrication of numerous components and subassemblies, including the fuselage, wings, engines, landing gear, avionics, and other systems. These components are manufactured using advanced materials, such as composites and metals, in state-of-the-art production facilities. The production of the Airbus A400M also involves a complex global supply chain, with various suppliers and partners involved in the manufacturing process. Airbus works with a network of international suppliers who provide components and subassemblies for the aircraft. These suppliers are carefully selected and managed to ensure that they meet Airbus high-quality standards and delivery timelines. Once the components and subassemblies are manufactured, they are transported to the final assembly line. The final assembly of the Airbus A400M takes place at Airbus' state-of-the-art facility in Seville, Spain. This facility is specifically dedicated to the production of the A400M and is equipped with advanced assembly tools and technologies. The final assembly process involves the integration of all the components and subassemblies to create the complete aircraft. Skilled technicians and engineers work together to install the engines, landing gear, avionics, and other systems, and perform rigorous quality checks and testing at each stage of the assembly process. Once the aircraft is fully assembled, it undergoes extensive testing and certification to ensure that it meets all the regulatory requirements and safety standards. This includes ground testing, flight testing, and other performance evaluations to validate the aircraft's performance, reliability, and safety features. The A400M is subject to stringent testing procedures, including structural tests, endurance tests, and environmental tests, to ensure its durability and performance in a variety of operating conditions. After the aircraft successfully completes testing and certification, it is delivered to the customer. Airbus works closely with its customers, which include various air forces around the world, to ensure a smooth delivery process. The customer acceptance process involves thorough inspections and verification of the aircraft's conformity to the customer's specifications and requirements. So, the production of the Airbus A400M is a complex and highly coordinated process that involves design, engineering, manufacturing, supply chain management, final assembly, testing, and certification. It requires the expertise of skilled engineers, technicians, and workers, as well as advanced facilities and technologies, to ensure the highest quality and performance of this advanced military transport aircraft. The Beluga is a specialized transport aircraft operated by Airbus, designed to carry oversized and heavy cargo, including aircraft components such as wings, fuselage sections, and other large parts. The Beluga is used to transport these parts from various Airbus production sites to the final assembly lines, including for the Airbus A400M Atlas. The Beluga features a distinctive bulbous fuselage, which allows it to accommodate large and bulky cargo. The loading process typically involves several steps. Prior to loading, the Airbus A400M parts are carefully prepared for transportation. This includes protecting them from potential damage during transit, such as covering them with protective coatings or packaging them in special crates or containers. The Beluga has a large cargo hold that can be accessed through a large upward-opening cargo door located at the front of the aircraft. The cargo is loaded into the hold using specialized ground handling equipment, such as cranes or loaders. The cargo is secured using straps, nets, or other methods to ensure it is stable and safe during transportation. Once the cargo is loaded and secured, the Beluga transports the parts from the production site to the designated final assembly line, which could be in another country or even on another continent. The Beluga is capable of flying long distances with heavy cargo, thanks to its high payload capacity and extended range. Upon arrival at the final assembly line, the cargo is carefully unloaded from the Beluga using similar ground handling equipment. The parts are then transported to the appropriate assembly stations for integration into the final assembly process of the Airbus A400M. The Beluga plays a critical role in Airbus global production and supply chain, enabling the transportation of large aircraft components efficiently and effectively. Its unique design and capabilities make it an essential asset in the production process of aircraft, such as the Airbus A400M Atlas, ensuring timely delivery of parts to the final assembly line for aircraft production. The Airbus A400M Atlas is manufactured at several Airbus facilities located in different countries. These facilities are part of Airbus Global Production Network, where various components and sub-assemblies of the A400M are manufactured and then transported to the final assembly line for integration. The main production sites for the Airbus A400M Atlas are Airbus Defence and Space Facility in Seville, Spain. This is the final assembly line for the A400M, where the aircraft is fully assembled and undergoes testing and certification. The Seville facility is dedicated exclusively to the production of the A400M and is the main assembly site for the aircraft. Airbus Defence and Space Facility in San Pablo, Spain. This facility is located adjacent to the final assembly line in Seville and is responsible for manufacturing the wings of the A400M. The wings are then transported to the final assembly line for installation. Airbus Defence and Space Facility in Bremen, Germany. This facility manufactures the fuselage sections of the A400M, which are then transported to the final assembly line in Seville for final assembly. Airbus Defence and Space Facility in Filton, United Kingdom. This facility manufactures the empennage section of the A400M, which includes the vertical and horizontal tailplanes, as well as the rear fuselage sections. These components are then transported to the final assembly line for integration. Airbus Defence and Space Facility in Tablada, Spain. This facility manufactures the horizontal tailplanes for the A400M, which are then transported to the final assembly line for installation. Various other Airbus facilities and partner companies across Europe. There are numerous other Airbus facilities and partner companies across Europe that manufacture various components and systems for the A400M, including engines, landing gear, avionics, and other systems. These facilities work in close coordination with each other to ensure a smooth production process and timely delivery of the Airbus A400M Atlas to its customers, which include various air forces around the world. The painting process for Airbus planes, including the Airbus A400M Atlas, typically involves several stages, including preparation, priming, painting, and finishing. The process is carried out in a controlled environment to ensure a high-quality and durable finish on the aircraft's exterior. The first step in the painting process is the preparation of the aircraft surface. This involves thorough cleaning and removal of any dirt, debris, or old paint. The surface is then sanded and smoothed to create a clean and even surface for the paint to adhere to. Once the surface is prepared, a layer of primer is applied to the aircraft's exterior. The primer helps to improve paint adhesion, protect the surface from corrosion, and provide a smooth base for the top coat. The primer is usually applied using spray guns or other specialized painting equipment. After the primer is applied and allowed to dry, the actual painting process begins. The aircraft is typically painted in a paint booth or a controlled environment to minimize dust and other contaminants. The paint is typically applied using high-quality paint sprayers that evenly coat the surface of the aircraft with the desired paint color. Multiple coats of paint may be applied to achieve the desired thickness and color saturation. Once the paint is applied, the aircraft goes through a finishing process. This includes applying any decals, logos, or other markings as required. Additionally, the clear protective top coat may be applied to further protect the paint and enhance its durability. Throughout the painting process, quality control measures are in place to ensure that the paint adheres properly, has the correct color, and meets the required specifications. Inspections are carried out at various stages, and any defects or imperfections are addressed and corrected as necessary. Drying and curing. After the painting is complete, the aircraft is allowed to dry and cure in a controlled environment. This allows the paint to fully harden and cure, ensuring a durable finish that can withstand the rigors of aircraft operations. The painting process for Airbus planes is carried out with strict adherence to aviation industry standards and regulations, and Airbus follows rigorous quality control procedures to ensure that the painted aircraft meet the highest standards of quality, durability, and appearance.